Hello everyone, welcome to Tuteetute. In this session, we will see the previous year questions. We have already seen some of the previous year questions from a different topic. We will see some more previous year questions. Okay, these are all previous year questions from the AEE of our Telangana and Andhra Pradesh state. Okay, so these are previous year questions from the NPDCL exam, EPDCL exam, SPDCL and GENCO and TRANSCO exam. Okay, you know, right, for the all these things the syllabus will be, electrical syllabus will be same only. So whatever you are preparing, okay, so see the all previous year questions. Okay, let's start. The first question we will see now. Okay, so in the circuit shown, the voltage across 4 ohm resistance V can be expressed as, okay, they are asking the voltage, the polarity also they have mentioned, plus and minus like this. And there is two sources. Okay, so two sources are there here, so they have forgot to give. This is E and this I will consider as I according to the options. Okay, you see this is in the E and this is in the I. Okay, I will consider like this. Okay, so two sources are there, right? We can apply any method to get the answer for this question. Okay, whatever method you know, okay, you can apply that method, there is no problem. Okay, so remember one thing, whatever method you apply here, follow the same method only. After that, don't think like second method is there, I will try and check in that method. Okay, so try only one method. If you are confident, you will definitely get the answer. Okay, so let's try. Okay, so two sources are there. I will use superposition theorem. Okay, I will use superposition theorem. You can use superposition theorem, otherwise you can use nodal analysis, you can use mesh analysis, or you can use any method. Okay, so whatever method you know, so you can use that method. Okay, so but let's see. So because of this voltage source, you will get some voltage. Because of this current source, you will get some voltage across this 4 ohm resistance. Okay, so let's check what is that voltage, what is that current and all. Okay, so let's check that. So because of the voltage source, for example, if I activate only voltage source, E is there, and this is the 6 ohm resistance, and this is the 4 ohm resistance. So directly, okay, what is the voltage? Because see this current source. Okay, so whenever only one source is activating means another source we have to deactivate. Okay, so deactivate means, so this has to deactivate means open circuit the current source. Okay, deactivation of current source. Okay, so deactivation of current source is nothing but current source. How you have to deactivate? You have to deactivate using open circuit. Okay, if it is a voltage source, okay, so voltage source, then we have to deactivate with short circuit. Okay, anyway, you know already this, so directly. Okay, so current source we have deactivated. We have to check the voltage between these two terminals. Total voltage is E. What you will get here? Okay, so according to voltage division rule, voltage across this one is nothing but total voltage into this resistance divided by this resistance plus this resistance. E into 4 divided by 4 plus 6 is nothing but 10. So because of this one, you will get 4 by 10 into E, that means 0.4 into E. Okay, so because of this source you are getting this one. Okay, so just remember this one, 0.4 E it is. Okay, because of one source. Okay, and this is superposition theorem, right? I am applying superposition theorem. Because of this source also you will get some voltage across this. Okay, so let's check. We have to deactivate this one now. Okay, so now let's see, draw the circuit. So this is the current I am drawing, and whatever current will go, it will be divided into these two. Okay, so this is the 6 ohms resistance, this is 4 ohms resistance, and here we have so E. Okay, so E, but we have to deactivate this one means, see this is a voltage source, we have to short circuit like this. Okay, so whatever current is going like this, it has to divide between these two. Okay, where you need the voltage between these two terminals, you need the voltage. Understanding, right? Between these two terminals you need the voltage. That means first I will calculate the current in this one. Okay, so whatever current is coming like this, so that sum of the current will go like this. I will apply current division. Okay, so what is the current division? I want current in this one. Okay, so let's calculate what is the current in this one means total current I into total current is this much coming. Okay, total current into, if you want current in this one, other resistance, okay, whatever other resistance, 6 divided by 4 plus 6, that is nothing but 10. Okay, so this is the current. Okay, so only current in this one, so that will be, so I'm just calculating as I2. Okay, so I2 is nothing but I into 6 by 10, so we'll get 0.6 I. Okay, this is the current. Okay, so this is the current. Directly if you see the option, okay, see first option will be first one. Okay, remember every time whatever you are solving, in between some steps will be there, first option will be that one only. Okay, don't choose that think once, okay? First option you are getting means just think just once, okay? 2 or 3 seconds, just think and answer after that, okay? So this is the current only, but we want voltage, okay? Voltage between these two terminals. And you see one more thing, okay? For a resistor, wherever current enters, that is plus, wherever current leaves, that is minus, okay? So if a current is entering like this is plus and this is minus according to this current direction. Understanding, right? But you see, we want voltage in this in these polarities, plus and minus here. So what I will do, so I will just reverse whatever voltage you will get, you will just take the minus, then you will get the answer, okay? So this is the current. If you want voltage in this second case, that will be equal to 0.6I into 4, okay? So into 4, but minus we will consider, okay? Because we want polarities in different, okay? So that's why 6 into 4 is nothing but 24, okay? So you will get as 2.4I, that is minus, okay? So total 0.4E minus 2.4I, this is the total voltage across this one. Understanding, right? So total voltage. Answer for this question is 0.4E minus 2.4I. This is the answer, okay? So there is no mandatory that you have to solve in this method only, okay? I can use in different method, there is no problem. Understanding, right? I can use different method. If you want, I will try 1 or 2 methods, okay? So just see. So what is the superposition theorem? We just understood, okay? So what is superposition theorem? The total response in some element is nothing but sum of the individual responses. Because of this source, whatever response we got, total response is nothing but sum of the individual responses, like that, okay? So that is the superposition theorem. And you know one more thing, okay? So this is the voltage source in series with the resistance, right? Voltage source in series with the resistance means we can convert as current source in parallel with the same resistance, okay? So I will consider this voltage source E in series with resistance. I will change as a current source. See, plus and minus is this side, right? Current direction you will get in the upside like this, okay? So and same resistance we have to use 6 ohms of resistance here, okay? And here we have 4 ohms of resistance. Understanding, right? So this is the current source value. I it is, okay? I am considering I only directly. So I want the voltage between these two terminals, which I will first calculate the current in this one, okay? So this current is nothing but, so what is the current value? I equal to V by R you will get. So that means E divided by, so 6 you will get, okay? So that is the current. Now these two are the current sources. Whatever current, total current, okay? So some current is going in this direction, up direction. Some current is going in downwards direction, okay? So what is the total current? If we consider, instead of these two, we can give as only single current source, that is nothing but, okay? So this I will consider as 6 by E by 6 minus I, like this. Understanding, right? This is the single current source. Now we have to apply the current division. I want voltage across this one, okay? So I will calculate this current first, okay? So current in this 4 ohms resistance is nothing but total current. What is the total current? E by 6 minus I into, so we want current in this one means other resistance, okay? Other resistance is 6 divided by 4 plus 6 is 10. We can do like this, okay? So and you can just simplify this one. So we'll get as E minus 6I divided by 6 into 6 by 10 you will get. So directly we can calculate this one, okay? So this is the 4 ohms resistance, so current, okay? So complete current it is. So I 4 ohms you can give as E by 10, that means 0.1 E minus, so you will get as 0.6I. This is the current in 4 ohms resistance. We want voltage. What is the voltage? Current in this direction we have calculated. Current in this direction we have calculated. What is the voltage means you have to multiply with 4, okay? So voltage in 4 ohms resistance is nothing but 4 into this one, okay? That is 0.4 E minus 0.6 into 4 I, okay? So that means 2.4 into I. Answer same only you will get. Understanding, right? May not be using this method, okay? Why to use this method? I will use different method, okay? I will use different method. You see one thing, okay? Whatever method you want, you just apply that method only. Nothing wrong you will get. Just be confident while solving this question, okay? So you will get another method, okay? Just nodal analysis you can apply, right? See, nodal analysis means I will choose this one as the voltage V directly. This is the 0 volts. You can write down the nodal equation. V minus E minus 0 divided by 6. V minus E divided by 6, okay? So plus V by 4, okay? So plus I is equals to 0. That's it. Directly we'll get the V in this case. Okay, so what you want? You want V only. Okay, so just check this one. So V minus E. Okay, so total we have 6 and 4 in the denominator. I will just calculate. Okay, so V by 6 plus V by 4 is equals to E by 6 minus, okay, so minus I. Okay, I want V. Okay, so V into, so in the denominator it will be, so 6 into 4 it is 24, and in the numerator you will get 4 plus 6, that is 10. Okay, so that will be equal to E minus 6I divided by 6. 6 ones and 6 fours you will get. Okay, so anyway, let's calculate. So this 4 will go to other side. Okay, so V is equals to, if 4 will go to other side, you will get, here 10 is also there. Okay, so 10 into V is equals to 4E minus 24I you will get. Okay, so that means V is nothing but 0.10, right? Divided by 10 means in the numerator we can write down as 0. Okay, 0.4E minus 2.4I directly. See this method. Okay, so using nodal analysis method, directly you got the answer. Okay, directly you got the answer. With only one equation we got this answer. Understanding, right? So remember one thing, advantage of nodal analysis, you can directly get the answers for most of the questions. Okay, so first try out, just practice the nodal analysis better, then you will get the, so some time reduction techniques, all these things. Okay, so anyway, in this, not only in this method, okay, you can observe even in, I'm not doing so, but you can just check with the, so mesh analysis also. You can do mesh analysis. Okay, so you know already current in this mesh is nothing but I, so I will choose some current in this one. Otherwise I will choose a current as I1. So any problems? There is no problem. Okay, so again we can get the same analysis. Okay, so whatever question they are giving, okay, if you are confident in some method, apply and get the answer. Okay, so speed is important for our exams, for AE or AEE, for any of the SPDCL, NPDCL, GENCO, TRANSCO. So this SSC junior engineer, all these exams, okay, speed is more important. Okay, so we have to solve within very less time. Okay, that's why practice previous year questions, you will definitely get that. Okay, next question. Consider the star network shown in the figure. The resistance between terminals A and B with C open is 6 ohms. Between terminals B and C with A open is 11 ohms, and between terminals C and A with B open is 9 ohms. The value of A, B, C are. Okay, so just given something. Okay, so first condition. Okay, so whenever you are reading the question, okay, understanding, whenever you are reading the question, read only one time. Okay, you should not read 4 or 5 times. I will read up to here. Okay, so what I have read, again I will read, again I will read, means you will lose the time there only. Okay, so that's why read only one time. Okay, any question you have to put concentration while reading the question. Okay, if you understand the question properly, you can definitely do that question. If you know the concept, definitely you can understand, you can do that question. Okay, so that's why, so first you have to read the question only one time with the concentration. Okay, that we have to habituate. Okay, so whatever they have given, you have to grasp within one time only. Okay, so the resistance between the terminals AB with C open. Okay, C open means C is not there, resistance between these two they have calculated, so you will get RA plus RB. That is what they have given, nothing else. Okay, so RA plus RB, so with C open means no need to consider this. Okay, so that's what they have given as 6 ohms. Immediately check the options, RA plus RB, everything you will get as 6 ohms only. Understanding, right? Check the options, 4 plus 2, 4 plus 2, 3 plus 3 and 5 plus 1, everything 6 only. Okay, check the another one. Okay, so between the terminals B and C with A open, with A open, B and C, if you check the resistance, what is the resistance? RB plus RC. Okay, RB plus RC is equals to, they have given as 11 ohms. Okay, so RB plus RC we have to get as 11 ohms. So we can eliminate this one directly. RB plus RC is equals to 11. RB plus RC is equals to 11. Okay, so remaining 2 only we got. Understanding, right? Next, third option is just C. Okay, so between the terminals C and A with B open, C and A, B is open. Okay, so between C and A, B is open means RA plus RC. Okay, so RA plus RC is equal to, they have given as 9 ohms. Okay, so RA plus RC, we have to check only these two. Okay, so RA plus RC we have to get 9 ohms. RA plus RC we have to get 9 ohms. This option is wrong. Okay, so immediately within 1 minute we have to solve all these questions. Okay, option B is correct one. Okay.